Good evening. Well, for me, midnight. Hello, guys. I would love to share my findings, my observations, and what I think, how I can explain to you the moon phases. And I think it's really quite simple and it really makes sense, and you will see why. So, what I'm going to use actually, I will call this tool of the fool. So, sometimes as you probably noticed, there's so many songs where people just don't realize, but flat Earth is all around the world. It's everywhere. It's in symbolism. It's in mysticism. It's in a religion. It's in materialistic things, and it's seen everywhere around the Earth. So I'm going to be using an application to prove my point and to demonstrate to you so you understand easily, and I'm going to use a calculator as well to verify my point. So this app, you can get it from the App Store. It is called Daft Moon. I recommend it. Well, I use it for tracking the moon, the planets, which are wandering stars. You can see, you can have a look at my few videos of the planets actually, and they are only lights. So this app. So at the moment, you can see it's just past midnight. The moon, the altitude hasn't risen yet. It's minus 17. Okay, so that's not important. So what I want to do, I want to get across the point how the phases of the moon work, okay, and how it relates to the sun directly. So you know the ancient symbols yin and yang, good and bad, and so on, light and darkness. They are working together, and this is how I'm going to prove it. So let's go to phases here, and I am going to go to the new moon, which was on the 5th of June 2016, okay? So now we see its new moon is at 0%, okay? That's to be seen here. So let's go, this app has a nifty feature. It's called Sky Sphere. So this will give you a good representation how it works. So please notice, okay, so these planets, I can make them disappear if you like, so it's easier to see. So let's go a bit forward in time. So now we can see the moon and the sun. So this is the, okay, look at the app. First of all, you do not see a ball. This does not represent a ball. Why? Because there's no ball, okay? As I said, it's everywhere. You just need to open your eyes. It's in songs, it's in everything. Flat Earth is everywhere. You just don't see it. So why do you think they make an app and they calculate it on a flat level plane? Hello? I mean, are you not seeing? Oh, are you missing something? So let's go one more hour forward, and we see the moon and the sun in the same location. Okay? So please take note of that. New moon, sun and moon at the same location. And if you look at azimuth down here, the moon is at 72 degrees, sun at 71. Keep a note of that, okay? Let's go to phases again. Let's take the first quarter, which is the 12th of June 2016, right? See, beautiful 50%. Let's go to Sky Sphere. Okay, now unfortunately we cannot see the moon and the sun at the same time in the sky. Well, let's try if we can do that. Oh wow, okay, so we can do it. Now look at the angle. Okay, this is the view from the top, from the firmament. Looking at yourself, so this is you, the observer in the middle, and you're looking at this from a level plane at the sun and the moon. Please note the angle. Okay. Now I can tell you that there are some discrepancies. I was just a few hours ago watching the sun set, and the sun was 30 degrees off location. Now I think this is to deceive us, just simple as, because that's just there. I believe this angle should be 90 degrees, which is not, it's more. As you can see, it's about 100 and maybe 105 degrees probably. So this is the angle I'm talking about, from here to here and from here to here, okay? It should be 90, plus minus few degrees, all right? So let's check another phase, which will be the full moon. So full moon, beautiful picture of the full moon, 99%. So let's go to sky sphere. And let's look at the sun and the moon. And let's make them both in a sky. Can we do it? 8, 9 o'clock. Okay. Nearly there, yes. Okay, we can kind of see both of them. Yeah. So please note the angle. Okay, so what is the angle? So we have 313 for the sun, the azimuth degrees, and 137 for the moon. So I'll get my calculator up here. Please excuse the ads. So let's do the math. 313, 313 minus 137 degrees is 176. So it's about 180 plus minus, okay? Few little inaccuracies. So we are going to change the phase again. And we are going to go to the 27th of June. Okay, 50% last quarter. So I'll go to the sphere. Can we make the moon and sun visible at the same time? Unfortunately not. However, again, I want to make a note and look at the angle, okay? Look at the angle. It's nearly 90 degrees, isn't it? The difference between just think of as extending the line from you, which is the little guy here, the flat earther on a flat level plane, looking at the sun and looking at the moon. So sun north and moon east. 90 degrees, okay, plus minus. Little difference there. And let's calculate that. 357 minus 84, okay? 357 minus 84 to 73, which leaves the rest, okay? So it's 90 degrees plus minus this angle here. From here to here, from here to here. So I'm not sure if you are already getting the point or not, but my theory is that. So let's go to another. Let's change the dates too. So I'll go to moon here. And let's change the year. Okay. Let's go to year 2018. So here we have a new moon, okay? 15th February of 2018. Go to sky sphere. Okay. So you see the sun and the moon. So the azimuth of the moon is 292 degrees. Sun 293 degrees. Okay. Now let's move a little bit so we can see them both in the sky. Just to prove my point, okay? So if you look here at them, now why you do, okay, let's look at the moon. It's 30.38 degree, 0.38%. All right. Now why you do not see the moon in the sky is simply because they are in the same location in the sky above your head. Okay. The sun is too bright and the moon's light isn't bright enough to shine, and this is why you do not see anything. This is why it's new moon. Still with me? Right. So let's go to full moon. 100% sky sphere. So let's do the math. We see the sun at 192 degrees. So 192 minus, and we have azimuth for moon 12 degrees. Exactly 180. Okay, that means right now, okay, let's make them both in the sky at the same time, a few hours more. Okay, so they're plus minus up, kind of. Well, the sun is just away from you. That's all it is. It's not below the curve or or below the ball. All right. So that's what we know. So we look at that. Exactly 180 degrees, which means the sun is on the opposite side in the sky from the moon. Therefore, the sun is not blocking out any light of the moon. Therefore, you see the moon 100%, as shown here. So let's go to first phase. Sorry, this is the last quarter. 50%. Okay, look at that. There's a little discrepancy. It's not 90 degrees, but I'm hoping you're getting the point here. And let's put the sun up in the sky with the moon as well. Can we do it? Probably not. We can do it, yes. Okay. A few hours more. Okay. So now you see both in the sky, okay? Look at that. 90 degrees plus minus, little difference there. We can make it 90. Look at this now. Yeah? You see both in the sky because they are in the sky the whole 24 hours. They are just going away from your view. So 90 degrees and you see 50%. Okay? 45 plus minus. Okay, this changes quickly. So the point is, again, it's just the angle. So this is why we see one side, and you see it's the left side. This picture shows you the left side is visible. Yes, of course. So it's showing you just one side of the moon. So the moon will only be bright enough to show you half of the full circle. Please note I said the moon is a circle. Yes, that's my theory. So let's change phase. And we choose 24th of January 2018. 50%. So let's check this out. Can we make them both appear in the sky? Can we do it? One more hour. Okay. The angle again, look at that. Now, isn't that 90 degrees, guys? Hello? Isn't that 90 degrees? Okay? And this time, the moon is to the left of the sun, okay? So in the previous phase, we had the moon to the right of the sun, and the other side of the moon was visible because now the sun is bright enough to cover or to shine stronger than the moon. That's why we see 50%. Okay? Still with me? I hope this is starting to make sense, guys. So every time you have a full moon, let's change the year. For example, 2022 sounds about right. But let's even go further, just to see if my point can be proven right or wrong, if this makes sense. 2053, yes, okay. Let's go here, and let's go to the new moon, January 20th, 2053. 0% new moon. Well, why is it full moon? Because, look at that. And we can make them both in the sky at the same time. So let's push forward. Okay, here. Look at that angle. So 127 degrees azimuth of the moon. Sorry. and 132. So it's the same. So again, same location in the sky. Sun is brighter than the moon. That's why you do not see the new moon in the sky. Okay? Change face. Let's go to full moon. See that? 247 degrees. Let's take the calculator. 247 minus the moon is at 70 equals 177. So if we tweak it, if we change in 1 hour plus minus, you see that? 180 degrees opposite yet again. Look at that. Why we see full moon? 100%. Because sun is not blocking any light from the moon light. Okay? So I hope this is enough to prove to you that we can use the tools of the fools. Here 50%. And we change the hour a little bit. This needs to be, they need to be both in the sky at the same time. Look at that. Come on, go up, go up. Can we have both in the sky? Yes, look at this. Okay, both visible. So this works only if they are both in the sky. Okay, they can't be far away because the angles won't be matching on the app because it's flat, guys. Look at that 90-degree angle, plus minus some discrepancy, but that's not important. The point is, again, the sun is blocking the half of the face of the disk of the moon. That's why you see 50% only. Okay? So I hope, guys, this is very helpful and this makes some sense to you. These were my observations for the past few months when I was shooting the moon, taking photos, making videos, and I just didn't understand and didn't have the proof. But now it's just somehow it was the right time and I felt the math was matching. Okay? And that's what it is. They show you flat plane in this app. Why they show you flat plane? Because it's not a ball. And they give you the positions of the moon and the sun. And you can see from the angles, it's always the same. It's always matching. The angle is 180 degrees. Look at that again. You can do this. We can do this all day long, guys. You know, you can change the year. You can go wherever you want, to which year you want. Doesn't matter. It's always going to be the same. When they are opposite of each other, look at that. The sun is not below the curve or below the pole or wherever. That's BS. The sun is just far away, but the angle is right, 180 degrees. Okay? That's what it is. This is why you see the full moon. Simple as. And when they are together on a new moon, look at that. Sun's light is too bright, therefore you do not see any moonlight. Zero. Okay, look at that, kissing each other, having a good time out there. That's what it is, guys. So thanks for the developer. Who is developer? Evgeny Fedorishenko, thank you so much. Probably, I don't know your nationality, but thank you for your tool to help us understand the moon phases. And also I want to point one more thing. So let's go here. And I want to ask a question to people who are living on the southern hemisphere, to be politically correct, hemisphere. So let's go here, for example, to these dates, okay? Now, the moon is going to be rising, okay? So let's go here. So the moon is just rising. You see, it is 1 o'clock in the afternoon, 26th of February 2053. So the altitude of the moon is 4 degrees. So now let's watch, okay? Let's please watch and focus now at the clockwise rotation. This is what I see in Dublin, and I want to see if people in the southern hemisphere see the moon's face, the disk, the picture, literally the picture rotating clockwise when in the sky or anti-clockwise. Okay, so look at that, it is going clockwise. Okay, while we see in the sky, clockwise, clockwise, clockwise. Now holding off and going anti-clockwise. Okay, now why do you think that is? That is going clockwise and then anti-clockwise. If you think you are on level Earth, well, of course, looking from below and the moon is above your head, once it gets past the distance that you can see it, of course, it's going to change the shape. So I'm thinking of the moon as it's attached to the firmament. Yes, I believe in the firmament. And this is how it's changing. And also it's traveling with the stars, which we can obviously see. I have a few videos that prove it, also the star trails and time lapses at night. I'll be doing more experiments, more comparisons. I have a few videos I want to compare also how the sun is not going below the curve, which now in summer in Ireland, there's a huge difference because I come from Slovakia, and at night, no matter if it's summer or winter, it gets pitch dark very quickly. It's slower in summer, but in here in Ireland, in summer, you see the sun in a far distance. You see a small light the whole night. Seriously. So how, where is that sun? How is it possible that it's illuminating the sky in the distance? Should it not be below the horizon? Actually, sorry, I forgot the horizon is flat. Okay, so it can't be. There's no curve. So please let me know what you think, guys. I hope I made sense. I hope this is clear to you. And I want to ask, please, FlatEarthers from the southern hemisphere. I know you don't live upside down. You know, if you can please confirm, is the moon moving from the left to the right in the sky, and also is the picture when the moon is up in the sky rotating clockwise or anti-clockwise for you? Please, I would love to hear your answers. Thank you so much, and have a good day, good night on Flat Earth. Much love.